guys out. So, class,
Yes.
thank you. I get a couple yeses. Okay. Vincent, Faye, you good? Okay. All right. So, Nephi, I get a yeah. Anyway, all right, let's go through and do some of this. So continuing, we're talking about the obtaining information about the graph of f from the graph of its derivative. So now, this is a derivative. That's important. So, derivative means that is my slope. So it's showing a graph of all my slopes. So over here, this is the point where my slope is 0. So that's a critical point. Another point, my slope is 0. Another critical point. Determine the critical points of f. There we go. Place in which it is going to be 0, or what else do I have to look for? Undefined. Very good. So slope is 0 or undefined. So that's good. So I get x equals 0 and 2. Where is f increasing? So now, what is the slope from here to here? All this slope here is negative, right? So it's all negative slope because it's below the axis. Remember, this is the graph of the derivative. It's not of the function. Okay? This also, it's in the negative. All this is in the negative. And right there, it changes to now be a positive slope. So I want to know, where is it going to be increasing? It's increasing from 2 to infinity and beyond. Decreasing is going to be from negative infinity to 2. At what number x does f have a local minimum? Now, think about that. Throw out those gang signs. Okay? Minimum, right? Minimum, so yes.
So when f is decreasing from negative infinity to 0, isn't that a positive slope because it's decreasing?
From negative infinity to 0. No, because it's the graph of the derivative. Remember, derivatives just help in the slopes. So, watch this real quick. Let's say right here. So when x is negative 1, what's the slope? Slope is negative 10, right? So this would be a negative 10. So all of this is of the derivative, so it just gives me a graph of all my slopes. So my x's are my inputs, and my outputs are my slopes for all these. So anything below the line is a negative slope. So that would be decreasing. Everything above the line is positive, so there would be my increasing. So yeah, it's a big change to try and think of it in terms of, just mapping out my slopes versus my normal functions. Seeing it going up and down. Zero what? 0, 0? Yes, 0, 0. Okay, so we're throwing up those gang signs, right?
Yeah, but when it's 0, 0, it's not increasing.
It's neither increasing nor decreasing, right?
And what if we set
That's kind of like a weird thing. I actually said the same thing, but it's still over that interval.
will the AP college board take it?
No, that's why I'm actually saying it like this, because I taught it backwards last time. I said, yeah, because when it goes to 0, 0 is neither increasing or decreasing. So that should be right. But then, according,
Most people don't like that.
yeah. So it was. We could check the answers in the book for those too. All right. So where am I at? Okay. So now, let's try it again. Local minimum. Minimum, throwing up gang signs. So that means that if I'm looking at the minimum right here, so that means my thumb is going down. So there you go. There's my minimum. So that means it's going to go like that. So that means my thumb would be decreasing. So that would be a negative slope, right? And then it goes down to the valley. That's my minimum. And then my finger goes up, and that is increasing. So it would be changing from decreasing to increasing. So that means from a negative to a positive. Does it go from a negative to a positive here on this? Yes. So right here at 2, that would be a minimum, a local minimum. And what numbers does F have a local maximum? Now, throwing up those gang signs again. Okay? That means that it is my thumb. There we go. All right. Wow. I have a special thumb there. Okay. The magic finger. Anyway, that would be my maximum. So that means that it's going from increasing to decreasing. Is there anywhere on my graph that changes from increasing to decreasing? Nope. There you go. Does that make sense now? Hopefully. Now, do you guys understand the reason for throwing up those gang signs? Even I go back through and have to look at it every time. So increasing, decreasing, or like when I was showing yesterday, the inflection point would be in changing in between my increasing and decreasing. So, yes. Yeah, there it is right there, right? Got that gang sign. Use first derivative tests with rectilinear motion. Suppose that the distance s from an object from the origin at time t is given by the function s is equal to f of t. Velocity of the object is the derivative of the position, which would be the distance one at here. So I would take the derivative of this. Okay, if the velocity is greater than 0, distance s, origin, is increasing with time t, object is moving to the right. This is important. All positive moves to the right. If it's negative, it goes to the left. So it's going to go move back to my starting point. If it is 0, object as rest. So, here is an example. From here to Douche Bros over there on, what's it, 7th Street, right? Is that where Douche Bros is? I never go over there, so that's why. So, alright. So, here to Douche Bros, I go from here to there and back. What would be my distance, my displacement? Am I back in my starting position? So in that case, it seems like I went 0 distance, right? Because when I went forward, I went to Douche Bros, right? Then coming back, would I have a negative velocity? Since I'm walking from here to there, I'm going forward. But coming back to my starting position, I have a negative velocity. Am I walking backwards? No, I'm just walking in this direction. So if you think about it, I'm going forward and backward, okay, going to douche rows and coming back. So my starting position is the same as my ending position. When I got to douche rows, am I traveling at all? No. Because that's my point where I stop right there, and every time I turn around and I'm changing from a positive to a negative, my velocity is going to be 0. No matter how good you are at drifting, okay, you're not going to actually, immediately change from a positive to a negative. Okay? Right? Yeah. Drifting through that school zone? Yeah. Alright. Object moving along a horizontal line, so its distance s from the origin at time is greater than t, or equal to t in seconds, given by s of, okay, there's my function. Determine intervals where distance is increasing, decreasing, all this stuff right here. So, I'm going to go to another page to do this one. S equals t3 minus 9t squared plus 15t plus 3. There we go. Alright, so first thing I'm going to do, let's go ahead and find my derivative. So if I'm calling it s, wouldn't that just be s prime? S prime 3t squared minus 18t plus 15. And this is every time you look at this math problem, you would say what?
Oh, wait.
F that, right? So what are we effing out of that? F that 3, right? Let's see, 3 quantity t squared minus 6t plus 5 equals my s prime, set it equal to 0, and then that 3 is going to go away, right? Because I'm going to divide both sides by 3. So t squared minus 6t plus 5. What are my two numbers? -5 and -1. So I get t minus 5, t minus 1. Now solve for t. So I get t equals a positive 5 and t equals a positive 1. Now, escriba una línea aquí, por favor, a las número 0, 1 y 5. Y 6. All right. Why did I add 0 and 6? Those aren't critical numbers. Yeah, I'm going to use those for positive and negative, right? Because using first derivative test, I just plug in numbers to what I have. And I'm trying to figure out if it's going to be positive or negative. So let's pick a number in here. Let's go 3. Why not? So at 0, so if I plug in 0, I get -5 and -1. Two negatives make it a positive. And And at 1, from 1 to 3. 1 to 3. So let's see, plug in 3. I get a -5 and a +2. So that's going to give me a negative right in here. And then the other side over here at 6. At 6. Let's see, I get +1 and +5, so let's say positive. All right, so now let's tell this story. Let's tell the story. So Christian is driving his whip through that school zone in that, 93 Honda Civic, okay, with a really loud exhaust on it, right? Yeah, okay. So, in this case, he started this way and he went to the right. He started by going to the right. But what happened at 1?
I hit a speed bump.
Okay, and what did that do to your car? Made you go backwards, right? Okay, because that 94 Civic, got that good transmission. So at 3, at 1, he just started going backwards. So at 1, he was going backwards all the way to 5, right? And what happened at 5? Became positive, right? Okay, you hit that other speed bump, which put the alignment back into your car, the front end. So when you hit a pothole and it fixed your alignment, that's pretty bad right there. So at 5, started going forward again. Intervals where distance is increasing. Where is distance increasing? 0 to 1, right? Okay, from 0 to 1. And 5 infinity. Yeah, I use 6 because that was just the next number I'm going to use. Intervals, distance is decreasing. So that means where he's coming back this way. So that was from 1 to 5. When does the object reverse direction? Changes direction from a positive velocity to a negative velocity at when x equals 1 and x equals 5. He's changing directions. Draw figure illustrates the motion of the object. Now, I suck at drawing this because I can never actually get it very good. So I'm going to show you, and we're going to just turn it sideways to make this work. Trying to remember what it was. Let's start with the position. We'll do that one. No, actually, let's not do the position. Let's do the velocity, because otherwise I don't want to confuse you. And there we go. There we go. All right, 3t squared minus 18t. 3 plus 15? I think. Plus 15. And I'm going to change my window. 0. Let's go to 10. And from negative 30. There we go. Okay. This is a graph of my velocity. So, from here, from the start, I'm going forward, right? I'm going forward right here all the way until 1, till this point right here, until 1, and then I decide, hey, I'm going backwards. So now I'm going backwards from this way, and then over here I start going forward. So, let's make it look like this. So, this is my distance. Here's a graph of my distance. So, starting, I go from here to 1. Okay, and at 1, I go back this way all the way till 5. And this is my V of 5. And so, and at 5, I go back this way. So these are the maps I'm not very good at actually drawing, because I kind of suck at these ones. But when you guys see it in the book, there actually is a couple good ones in the book where they use for some of the homework assignments. You got the book right there, right? It is... so I can show you guys. So yes, it's going to look like this. All right. So that being said, I am going to stop here before we actually get too far into this next part, because I want you guys to try some of these out already, where you take the derivative, okay, and you answer the questions that go along with it. Concavity is where it changes. That's called a point of inflection. It's changing from concave up to concave down. So, let's see, hold on. Oh wow, that is horrible. Wow. You know what? And I tried so hard and got so far. But in the end, it doesn't even matter. Anyway, so throwing out my gang signs right there. I put two gang signs together. That point right there would be the point of inflection. That's where it changes from concave up to concave down, or vice versa. Does that make sense of what it actually is? So, other than that, I'm gonna let you guys work on the assignment, and I wanna ask you guys, so do you guys want a